right, so I talked to you very briefly at the beginning of this about the fact that these are conic sections, and they are sections of a cone when a plane slices through the cone and gives you a cross section. So we talked about circles, we talked about, and that comes through parallel to the base. We talked about ellipses, right? This is when it comes at an angle, but greater than the slope of the generator line, and I'll show you what I mean by generator line here. And I'm not even going to attempt to take these two off because you can see them and they just don't work very well. I'm quite sure I would drop this today, but you've got the parabola here when it goes through at an angle that's different than the generator line, and then when I turn this upside down, which I'm not going to because it'll fall apart, then you slice through and you get two slices right here, which is going to be the hyperbola, which is what we're going to talk about today, which is different than hyperbole in English. Okay, but I want to show you just a quick, I put these in the playlist too. I'm not sure if yeah. These are really just animations. Well, this first one is just an animation. There we go. I don't think that there's no sound to either one of these. And I probably playing the wrong one first, and I am, but that's okay. I'll tell you what I mean by we'll talk about this generator line. But here you see when it comes through and it comes closer and closer to the vertex, it becomes a point, right? But as that plane slices through and moves through, you get a circle, and you can see how it's being graphed over there. Okay. All right, and then when it doesn't cut the cone, what do you think happens? Nothing. I don't know, it seems like an odd thing to put in there. If it doesn't cut the cone, you get no graph. There's a conic section of nothing. I don't know. And then your ellipse is created when a double-napped cone is cut at an angle less than 90 degrees and greater than the angle of the generator line. But that's where you get the ellipse. And it kind of looks like a circle on the graph, but it's not because it's going through at an angle. You can tell when it's graphed, it's, you know, not exactly circular. But the more different the angle is, the more oval your ellipse becomes. And it can degenerate to no graph. All right, so angle of the plane is equal to the angle of the generator. So you see the lines that are drawing that cone, and I'll show you what that actually means by that. But when that plane is the same angle as that, what you're getting then is a parabola. And you can see how it changes as you go through. Then you get to a line. Okay, so you can slice through and get a line. A line is a, kind of a special case of a parabola as far as a conic section is concerned. And then there's your parabola when the plane goes through the other side. And then hyperbola is created when the angle of the plane is less than the angle of the generator. And that's when you're going to get two. And that's why you need that double napped cone, because there it actually does go through twice. Oh, I think I hit something. All right, so I started it over because I hit something. I was trying to come over here so I could hit escape and get out of the... I can't see over here. All right, let me fast forward to the... There we go. So we were here, I think, when I cut us off. I think it's just going to go through and just show you the same thing. But you get two intersecting lines there when what it degenerates to. So and then so that's how you get the conic sections from the cone. I know I showed you an actual cone, but I liked that this showed the graph next to it. And then the other one shows you what I mean by the generator line. And I better stop this or it's going to like play the next video. Oh, see, and we don't want that. It's probably going to play the same stupid video because I pulled up the wrong one. That's what I thought. This is what I want right here. No wonder I showed you the wrong one first. So here's the generator line. It's going to show you how you take the two lines and you got intersecting lines. Then we have an axis of rotation and we're going to revolve those lines. Remember when we revolved things and we got three-dimensional figures? When we revolve that, that's where your cone comes from. So that's why that's called a generator line, because you take the two lines and when you revolve it, you generate the cone. Okay, and then this shows you the cross sections too. It just didn't do as good of a job as explaining it as the other one did. So I'll just let this one finish by the time I get back up there. It goes a whole lot quicker. And there are your conic sections. All right. There we go. All right. So let's go and look at what's going on with the parabola. Now, as we've gone through these, we've had more and more stuff on each one of them. Close these out so they don't start playing again in the background. And so this one has even more stuff we have to pay attention to. This is going on page 156 when we're done. So you get two parts of the graph. It kind of looks like two parabolas. Cody. Kind of looks like two parabolas, but they're not exactly parabolas, right? There was different angles going through our cones. But we could have vertical and horizontal, all right? And we still have axes, like we had a major axis and a minor axis with an ellipse, but these are called different things than that. But we still have foci, we still have vertices, co-vertices, but now we also have asymptotes. Remember asymptotes? Okay. And this also looks very, very similar to the standard form equation of what? An ellipse. Okay. But one of the main differences is that this is a subtraction instead of addition right there, and how A and B works, right? Remember that A was always the bigger number for ellipses. For hyperbolas, that's not the case. A comes first both times. So A could be it's not necessarily the bigger number, it could be the smaller number, but the A squared is in the first fraction, B squared is in the second fraction. Whether X or Y comes first depends on whether it opens up like with the x-axis being, well, and it doesn't always have to be at the origin, but you can think of it as opening in the x direction or opening in the y direction as far as which one comes first, okay? Well, okay with that in general so far? Now, you've got the focus points. They still open around the focus points, right? And then you have these two axes here that are different. They're called the conjugate axis and the transverse axis. Okay, transverse and conjugate, and we'll go in there and label them in just a minute. And you see this little box that we have here? This box is helpful. That's where your A and your A goes to your graph, but the B doesn't go to anything that's really something that you graph, but it is something you need to help you to get how big this box is so that you can get your lines there. Now you can do it all with just the little ordered pairs and plus or minus A and B, but understanding how to make it work with the graph can help you develop it as well. So let's come down here and label some of this stuff. We have this point right here. It's still the center, but notice the center is kind of what you might think of as on the outside of the graph. But we're going to label that as HK and not with a C right now because I don't want the C part to confuse you. All right. Okay, so then you have these two axes here. This right here is your, well, from here to, I'll do it on that one. From the center, I'm going to change courses. We'll talk about the axes here in a second, but from the center to the graph itself, or to right here, which would be the vertex. I didn't put the point on there because I couldn't get it on the right. So this is the vertex, and this is the vertex. Okay. When you go from the center to the vertex, this is your A. These points here that aren't technically on the graph itself are the co-vertices. And just like before, A goes to the vertex, and it's B that goes to the co-vertex. And just like before, it is C that goes to the, what point do you think that is? The focus points. Okay. So then what we have here, we'll label on this next one. I just gave you one that was turned. It's the exact same picture. This is your HK, and we'll label the axes here. from here to here is 1. So since this is b, this is also b, right? So the whole thing is 2 times b. And then we have this one here. So this is a, so the whole thing is 2 times a. This one that is the 2a is called the transverse axis. Okay? Trans meaning going across or through, so that's the one that would actually be touching your hyperbola. So transverse axis, and then this one is the conjugate axis. So it's not major and minor, it's transverse and conjugate. So as you can see from right here, and we'll go ahead and fill this in here, your transverse axis is 2 times a, because from the center to that vertex right there is a. So the transverse, the length of that is 2a, conjugate is 2b. Same thing in both forms of the hyperbola. Okay. The length of the focal chord, we'll go ahead and kind of finish this off right here before we go back up to the top, is the same as before, 2b squared over a. And I know you don't have enough room in that blank, but I couldn't organize it in a different way. So 2b squared over a. You just have to do a slashy fraction, which I'm not a fan of, but it'll make it work right here. Cody Robbins, boy, I'm going to make you get up and do jumping jacks. All right. Think I'm kidding. We're going to have a little workout in a minute. I know this is not the most exciting thing in the world, but you're hurting my feelings, okay? All right, so now I'll look back up here on both of these, and what is always true, even when you mix up x and y and you mix up a and b and stuff, your center for all of these is HK. Center is HK every time. The vertices are always in line with the foci and the center point on the ellipse and on the hyperbola, which means that if this has a, I don't know what they actually call it on here. Well, they didn't call it either way, but you can talk about it being a, you know, if it's going to open left and right or open up and down, however you want to think about that. But when it opens towards the x's, then that's what's changing. It's all lined up with the x values that are changing. Your y value stays the same for the vertices. So your vertices are going to be h plus or minus what? A. Good. Comma k. Your co-vertices, that's your y changing when it has an x orientation like this. So this is going to be h, comma, k plus or minus b. Right? That should look familiar as well. Foci, again, in this one, it's the x that's changing for that. So h plus or minus c, comma, k. And if you can jot this, like, let's say that you didn't have to graph it, but you were trying to figure this stuff out, you can make yourself a quick graph to try and figure it out too. If the whole, I don't remember if I'm adding or subtracting, if you can get the idea of what's going on with your graph, you'll be able to figure out which way you're going. So if I have a y orientation here, the up and down, then my vertices are in line with the center point and the foci. So that means my y is changing. So this is h, comma, k plus or minus a, right? Co-vertices would be h plus or minus b, comma, k. And then h, comma, k plus or minus c. All right, everybody good so far? We've got to write the asymptotes, so we're not done yet. Because now we also have to write equations of lines. But here's the thing. It's not going to be that bad. Okay? So I remember back in the day, and I would be willing to put money on it because the same thing's been true for years for me. When y'all come into geometry and you're like, oh yeah, I can graph a line, and like you are in love with y equals mx plus b. And I try my hardest to break you up and you'd lose your love affair with y equals mx plus b, right? Because it isn't the end all be all, right? Point slope form, way better most of the time, right? And so here, I don't really care about the y-intercept or anything else. Point slope form is great. So if you look at what's happening here, right? This point is the center point. Isn't that going to be a point that's on both of the asymptotes? So I got a point. Bam, there you go, right? And then you need the slope for point slope form. Well, guess what? If you know what B is and you know what A is, isn't this going to be another point, and can't you get your slope from that? So you see how easy it is? It's not that big of a deal at all. And so your asymptotes have very simple little equations that look very similar, but you got to make sure we keep them straight, and we'll talk about how to exactly keep them straight when we are doing an example. So we'll just, instead of rewriting the word, we'll just point there our asymptotes, right? Both of these have the y minus y1. So if we're using the center point, this will be y minus k equals, now we'll leave a blank for the slope right here, and then x minus h. All right, so we'll come back and put the slope here in just a second. So the exact same thing happens right here. It's y minus k is equal to, leave a space, and then x minus h. Well, the nice thing about the slope is that you can just do a plus or minus, and plus or minus, and we're going to make a little fraction. And your slope is always rise over run, right? And so if you have this orientation here, because this is the one we can see right here, your rise is A, your run is B, right? So your rise over run is A over B. So your rise over run for this one, your rise is B, your run is A, so it's just plus or minus B over A. So see how they're super similar, but what changes is the fraction that is your slope. And so if you just look at your graph and think about which one is your rise and which one is your run as far as your B and your A, no big deal. Plus, if you look at this and you look back up here at these equations that you have in that nice pretty one that I printed there, when you think about rise over run or your y over x, what is B underneath? In this, oh, y'all don't understand my question. In this nice pretty thing, right? You see how the B is underneath y? So when you do rise over run, it's B over A because it's y over x. And when you do rise over run here, it's y over x still, and it's A over B. So if you understand the equations, you can make sure you get the A over B or B over A thing correctly and look at it that way. Or you can look at your graph and you'll know what your A and B is. It's really not that big of a deal. Just understand that they're different. And if you think you're getting them confused, there's a way to kind of reason through what's actually happening here on the graph. Okay? We good? All right, let's go do some examples. All right, so it says graph the following conics and find the missing information. All right. So A and B are always pretty easy to find when you're given when it is given to you in standard form. Now, is A the bigger number or is it the first number? It's the first number, and in this case, it's both, right? So this is actually A squared. This is A squared, and this is B squared, so we don't mess that up. And this is 4, so B is 2. Oh, and I glossed over something here. Let's go back real quick. You don't have to rewrite it, but I didn't talk about it. Remember how we had for the ellipse, C squared was equal to A squared minus B squared, and we had to make sure we knew it wasn't the Pythagorean theorem? Well, for this one, C squared does equal A squared plus B squared. So it is just straight up the Pythagorean theorem, and that's what it is. So when you have this right here, you see how you have this? This would be your A squared and B squared, and you can get it that way. You just take that point and swing it up there. That's your focus, because that's the C also. So in order to find C, finding C is very easy, but C squared is equal to A squared plus B squared. It's the opposite of what's happening here. So for ellipse, this was plus, which means it's minus over there. And for this, it's minus, which means this is plus right here. So that gives me C squared is equal to 16 plus 4. So C is the square root of 20, which is 2 square root of 5. And that is about 4.47, yeah. So this is the actual number I use, but I need to know that that's about 4.47 just for graphing purposes. Okay. All right, so now I can look at this and I can come up with my center point, right? What's my center? Negative 3, 2. So I'm going to go ahead and go graph that. This is negative 3, 2. And that's my center point. So is it going to open up and down or left and right? the one that comes first is x, so it's opening up along the x way, right? So we're going left and right. I know what A is. A is 4. So from C, I can go 1, 2, 3, 4. 1, 2, 3, 4. Now, what is that? Is that a vertex? Is that a focus? What is that? When you use A, you get the vertices or the foci or the covertices? Vertices. Okay, so I'm going to label it vertex. Because you're going to have points here. You definitely want to get vertex mixed up with focus and whatnot, because just bad things happen then. So now I have my points. And see how I can either get it from my graph if I understood what A was, or I can understand that it's plus or minus A, whatever works for you, but make sure you can do it in both ways. So I know my x value is changing, so that's -3, and I had to subtract 4, so that's -7, 2. And -3 plus 4, that's 1, 2. And then I can double check that I actually graphed them right on my graph, which I did. And it doesn't matter which one comes first. Whatever you can handle better is fine. Then can we find the covertices pretty easily? Yes, let's do it with the ordered pairs first this time. So covertices, we are adding and subtracting the to the y value. So my x value is -3. I use the b, which is 2, to add and subtract here. So 2 minus 2 is 0. And then -3, 2 plus 2 is 4, right? So then I can graph those, and I'm going to go to -3, 1, 2, 3, 0. There's one covertex. And then here's the other one, which again, I could have just done by counting from the center point, but we want to make sure that we understand both of them. Now, the rectangle is important to us, but it's not really, we don't have to draw in the rectangle. All we really care about are the corners so that we can get the lines drawn in there correctly. We can find the equational line and then go graph it that way, but it's really easier just to understand that this is, if this is my covertex and this is my vertex, isn't this the corner here? Covertex, vertex, you just find the corners of your rectangle. And then you know where to draw in your asymptotes, right? So I would suggest using a straight edge like your ID badge or maybe a ruler if there's on your table. I'm going to try and do a dotted line without a straight edge, which is probably a bad idea, but see, my shadow's in my way. So those need to be in there because that's going to help you with the shape of your graph. Then I need the foci, and the foci are going to be in line with the vertices and the center point, which means my x is changing. So I take the center, which is -3, and I would subtract 2 square root of 5, comma 2, and then -3 plus 2 square root of 5, comma 2. So I could get the decimal approximation for that if I wanted to, but I have this one. I mean, it's 4.47, and so that's how far I'm going from the center. So go 1, 2, 3, 4. That's about 4.5 on a small graph like this. So here are my foci. Then my focal chord length, remember that is 2b squared over a, that hasn't changed. So that's going to give me 2 times 4 over 16. That is not right. What did I do wrong? B squared is, I did, yeah, 2 times 4 over a, that's why. I was like, something is wrong. What did I do? Over a, I did a squared. Thank you. Dang it. I knew I was wrong, but I couldn't figure out what I did wrong. Okay, 2 times, that's b squared. Thank you. And then a is just 4. I was using a squared. No wonder. Whew. So the 4's just cancel out, so my focal chord length is 2. This is one reason why I work them out before. I was like, I know that was right the first time. All right, so then here, That means since my focal chord length is 2 from my focus, I go 1 on either side of it to get my other points there. And then I'm going to draw in my shape of my graph here. And remember, this is an asymptote, so it gets really, really close to that line, but it goes to the focus, the focal chord points to help you get that shape in there. There we go. Still got to write the equations of my asymptotes, right? So I've already graphed them. Now you can just take, go from the graph and figure it out that way, but nobody really wants to do that. You just take y. It's just this term. It's y minus 2 and x plus 3. I mean, that's what I'm using, but not squared. So y minus 2 equals, and then this is going to be x plus 3, and then this is plus or minus something, right? And since we're going this way, I want the slope of this line. Slope is rise over run. So my rise is 2, and my run is 4. So 2 over 4 reduces to what? 1/2. We good? Any questions at all? All right. Lots of stuff there, though, right? And so doing it a piece at a time, sketching it, even if you didn't have to have a graph, if you need to figure those things out, most of the time you're not going to be asked for those things if you don't have a graph anyway, but you can do it from one or the other, whatever makes the most sense to you. All right, so now let's look at this one. Now, what is my A value? 3, right? Because it comes first. It's not the bigger one. My A is 3, or could be the bigger one, but not necessarily. My B is 4, right? So to find C, C squared is equal to A squared, which is 9, plus B squared, which is 16. So C squared equals 25. What is C? 5. So that's really nice. That's a 3, 4, 5 triangle. Okay, we all good with that? My center point, what's my center? 1, -2, good, because it's always HK. So 1, -2. Let me go ahead and graph that. 1, -2, there's my center point. Now, is this going to open vertically or horizontally? Open up and down or left and right? Up and down, because your y is the first term here, which means it's opening up in what you can think of as the y direction vertically here. So that means that oh, holy heck. Oh no, that's okay. Sorry, I had this bad feeling I messed something up. Because it's HK. Okay. Sorry, I just had this moment where I was like, oh dang, I think I did something wrong. But I did not. This is good. I did not. I just wanted to check myself before I moved on. I was like, I think I just said something wrong, but I did not. Okay, got this. All right. So what threw me off was that since A is always the bigger one on the ellipse, I had this bad feeling like on the transverse it was supposed to be B on this one, but it's not. And I just was like, all right, so we're here. My A is 3. Since I'm opening up and down from C, I can count A to get to the vertex, and I can count A to get to the vertex here. There are my 2 vertices, right? Which means that this is 1, comma, and then 2, or -2 minus 3 is -5, and -2 plus 3 is 1. Okay. And those are the points that I have, 1, 1, and 1, -5. So my co-vertices, I use the B version, or the B value rather, which is bigger than A, and that's okay. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. This is my co-vertex. Co-vertex. So that means that's going to give me 1 minus 4, which is negative 3, negative 2, and 1 plus 4, which is 5, negative 2. They're my co-vertices. So I'll go ahead, even though it asked me for the asymptotes last, I'm going to go ahead and put my points in here and get my asymptotes drawn, because I need those before I draw the rest of it anyway, because that helps me with the curve. So there are my asymptotes. I now need the focus. So the focus uses C. So my focus going to go vertically from my center or horizontally? Vertically, because it's always in line with the vertices. So from the center, I can go 5, and that's a focus. From the center, I can go 5, and that's my other focus. So again, I know that my x value is staying the same, which is 1. And see, I'm kind of doing half and half here, the way I'm talking you through it. Like I'm using my graph, but I'm not counting on my graph. I'm just thinking I can use that to go, all right, well, I know for the focus value, the 1 stays the same. And then what I did was I added 5 to the center value, so negative 2 plus 5 is 3, and negative 2 minus 5 is negative 7. And then that's where I'm getting it. So you can it's kind of a hybrid the way I was looking at it. All right, so focal chord length, 2b squared over a. Let's see if I can do that right this time. So b squared is 16, so 2 times 16 over a, which is 3. So that's going to give me 32 over 3. We don't need a calculator to estimate that, right? That's like 10 2/3, right? So about 10.7-ish. Good enough to, so if it's 10 2/3, then half of it is how much? 5 1/3, right? So 1, 2, 3, 4, 5 1/3. 1, 2, 3, 4, 5 1/3. And then do the same thing down here. 4, 5. 1, 2, 3, 4, 5 1/3. And I realize now that I probably should have made my asymptotes a little bit longer so that I have something to hug as I draw it. So I'm going to extend mine a little bit. And they're lines, so we want arrows on them. Okay. And then I can go and draw in my shape, hitting the points on the focal chord and staying tight against the asymptotes. There you go. Everybody okay with that? All right. So let's take these and write these in standard form. I left you tons of room because I thought we might graph them quickly if we have time. We're not going to have time and we don't need to. But you're going to do this the same way we've been getting the other ones in standard form, and that's by completing the square. But you got to make sure you know which one's coming first. So you look at your y squared and your x squared term, and having it like that can tell you right there it's not an ellipse because the signs are different. So which one is going to have to come first, y or x? Y, okay, because the positive one and then it's minus whatever. So I've got 2, you got tons of room to write, you usually don't have enough. 2y squared, I'm going to put that first, plus 4y, okay, and then I'm going to have to do something there, right? Then minus x squared, I don't have another x squared term, so that's nice. And that is equal to, I'm going to move my 4 over there. then I have to make sure that since I have this, I have something in front there, I have to factor that out before I complete my square. One of the things I did get completed that I was grading for y'all, some of the completing the square stuff, not so good. We hadn't even gotten to the point where you had to factor it out yet because I was looking at the circle one, but I'll tell you the mistake that was made multiple times here in just a second. I don't have another x squared term I have to worry about here, but if I did, I'd have to make sure that I factor out that negative, okay? So I'm going to take this 2, and when I factor it out, that leaves me with y squared plus 2y, and then here's what I complete the square with, plus 1, right? And then this negative, it's like negative 1 times x squared, but there's nothing there, so it's just minus x squared, and that's fine. But then I have this 4 here. Here's what wasn't happening with some of you. When you complete the square, you have to balance your equation. So whatever you add over here, you have to add over there. But in this case, I'm not just adding 1. I have to take that 1 and multiply it by 2, so I'm really adding 2 over there. Does that make sense to you? Be careful with that. And then this, so that gives me 2 times y plus 1 squared minus x squared equals what? 6. Okay. Then the last step to get it into the form I really want is to do what? Divide. I'm going to divide everything by 6. And then you reduce. So I reduce this, and this becomes y plus 1 squared over 3 minus x squared over 6 equals 1. And there is your equation in standard form. Okay. It's like algebra puzzles. Aren't they fun? Yeah, you know you like it. Don't even pretend. That's what Cody's dreaming about when he's sleeping. He's like, oh, I just love this. I've got to dream about it. Okay. While I'm going to pass out the homework. I want you to complete the square on the second one. Okay, because y'all were struggling with that. I want you to do it. I'm going to pass out the homework, give you a minute, and then I'm going to stand up here and work it. But don't be looking at mine until you're done. Because on the on here, since it's subtraction, it matters which one comes first, right? And so we don't start with the negative one. We start with the positive one comes first. So that's how I know it's going to be a y squared when it starts, because the x is negative. So you take whatever group of stuff that's positive, and that's what goes first.
So since this one's positive,
We start with yes, 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 absolutely. Okay, I'm going to start working this, but I don't want you to watch me. I want you to try and finish it on your own first. Uh-huh. Oh, are you kidding me? What happened to my equation? Oh, God. Okay. Well, yeah, freebie, and I'll just put another one like, I was trying to just give you, instead of, I also realized on the circle one, I gave y'all like way too many problems. And I even had worked them all, and then I was like, God, why did I give them so many? So I was trying not to give you as many, but I wanted you to have like one of each, so I'll just throw one of those on tomorrow's. That's fine. Just omit number 1. I'm telling you that well, I guess as many times as it shut down, I finally lost an equation, but the rest hopefully is, yeah, the rest is what I actually put on there. Yeah. All right. Yeah, careful when you're factoring out this negative 4 here. Okay, so do you see what was happening there when you were completing the square? Okay, first of all, when you factor out that -4, that becomes a positive 10y. And then when you are balancing your equation, this 25 gets multiplied by a -4, so technically you're subtracting 100 over here, so you have to subtract 100 over here. That's where you get your 36 from. Okay. Then I divide everything by 36. Otherwise, you've probably got a pretty strange number, huh? Yeah, and you're like, what the heck? So the good news is, hopefully you will get weird numbers if you do something wrong, so it'll at least alert you that something's not right. And then x minus 3 squared over 4 minus y plus 5 squared over 9 equals 1. Okay, so any questions about the whole completing the square thing there? Be careful with that. Right? You got to factor these things out, and then you got to use your multiplier and pay attention to the sign when you're factoring out and when you're using your multiplier. We good? All right, have a great day. I thought I was going to have extra time today. I was like, oh, we'll just, yeah, no.